Hi there, welcome to this lecture. We're going to continue from where we left off in the previous lecture. And I'm going to build upon this concept of having a thread and then running it in the main method, or starting a thread inside of the main thread. So as you can see on line number 8 here, we are starting a thread, and then later on we're starting another thread. So let's have a print line statement right before the thread is started. And this is just going to sort of reinforce the points that we covered in the previous lecture, just so you have more fodder to play with. So I'm going to just say starting thread 2, because that's what happens in this set of code. And I'm just going to copy this line and put it right before thread 1. So over here it's going to say starting thread 1. And you can actually name your threads. So I'm going to show you exactly how to do that in just a second. This loop prints out all the numbers very quickly. All right, so to simulate a more realistic example where some useful work is being done in an application, I'm just going to slow down this loop, and we can just, imagine that it's doing some useful work, such as, reading data from files or downloading stuff from the internet and so on. So to do that, I'm going to slow this loop down. And for doing that, we can use this method on the thread class called sleep. We can sleep the thread for a small period of time. So within this loop, where it's printing the numbers, I'm just going to say thread.sleep and then give the milliseconds that I want to sleep. So let's just say 10 milliseconds. And notice that we've got an error. If you hover your mouse, it's saying that we need to surround this with a try and catch block, because it's going to throw an exception called the interrupted exception. We can verify this by going to the sleep method in the thread class. If I control click the sleep method, notice that this throws the interrupted exception. Okay, so let's handle that exception by surrounding this with the try catch block. So let's click that, and there we go. We surrounded the piece of code that could throw some kind of exception in this try block, and then we're catching the exception here in this catch block. So I'm just going to get rid of those comments. We don't need those there, and I'll leave the default here, printing to the stack trace. And now running this example is going to make things even more clear for you to understand how threading works. So let's hit play here, and notice that it's printing those numbers. It's doing a slower job, but let's hover all the way to the top, and notice it's saying starting thread 1 and starting thread 2. So at this point, starting thread 1, we were supposed to have started the first thread, right? So this was started, but then it moved to the next line and it printed out starting thread 2, and then you can see 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and so on. Okay. Again, the reason for why starting thread 1 and starting thread 2 is being printed first is because it takes time for a thread to spawn. But the main thread is going to run through all of this code, right? So it's much faster to print something to the screen than it is to create a new thread. So while these threads are spawning, the interpreter has already gone through most of the main thread. It ended up printing this line and printing this line as well. Now you might be wondering if there's a way to find out which thread ran a particular line of code. So for example, here we've got number printed with 0 twice. Okay, so one of these numbers is being printed from thread 1, and the other number is being printed from thread 2, and so on. You can go through this code, and you'll notice that the numbers are all being repeated. Each number is being printed twice. So one of them is being printed from one thread, and the other one is being printed from the other thread. So there must be a way to find out which thread caused this number to be printed out. To do that, we can invoke the getName method of the current thread. Inside of this print line statement, I'm just going to concatenate another piece of string here. We'll put a dash and then plus. We'll do thread dot current thread. Right, this is a method on the thread class, dot getName. Okay, so now each number that's being printed will also have the particular thread that caused that number to be printed. Okay, so let's hit play, and boom, notice that if we go all the way to the top, we can see which thread caused which number to be printed. So here thread 0 represents the first thread, and thread 1 represents the second thread. And if you scroll down, you'll notice that each occurrence of a particular number has the thread listed next to it. So the first occurrence of the number 0 is printed by thread 0, and the second occurrence of 0 is printed by thread 1. But here for the number 1, its first occurrence is actually being printed by the second thread. So it doesn't necessarily mean that just because this is first, it's going to print that first occurrence of a number first. It could actually be this guy that's printing the first occurrence of the next number. So by default, Java basically names the thread with the word thread followed by an integer. So thread 0, thread 1, if we had more threads, it would have been, thread 2, 3, 4, and so on. That's the default naming convention Java uses to name threads. But we can actually set our own names for threads. And to do that, we use this set name method. So here, if I was to do thread.currentThread.setName, instead of getName, if I was to do .setName, I could set the name of the thread. And so now I think is a good time for you to work on an assignment. And you have enough knowledge up to this point to be able to complete it without a problem, hopefully. But basically, I want you to be able to name both of these threads. We have 2 threads, and currently they have the default names thread 0, thread 1. Okay, I want you to be able to name these threads with something specific. So the first thread is not going to be the default, thread 0. I want it to be named thread A, right? I want thread A to be the name, and then for the second thread, it should be thread B. And you can do this using the set name method. So this get name method exists, so does set name. So I want you to be able to use the set name method to set the name of each one of these threads. And you're going to need to change this task class, okay, to be able to facilitate the ability to name the given thread, all right? So I'm going to leave this up to you as an assignment. You can pause the video, try this out, and then you can resume to watch my solution. Again, you're going to have to change this class definition for task to be able to allow for someone to be able to name the thread. So if I was to name this thread up here, let's pass in an argument and call it thread-A, and for the second thread I want it to be thread B. You should be able to know how to do this. So give it a shot, pause the video, try it out, and then you can resume to watch my solution. Okay, so welcome back. Hopefully this wasn't too challenging. This is more of an object-oriented assignment, really. It doesn't have much to do with multi-threading. I already told you that there is a set name method on the thread class, so you could use that. First thing we're going to do is give this task class a property with the data type string, and we'll call it name. All right, and we're also going to give a constructor to this, so we can do public task, and the argument to this is going to be the name that's going to be passed in. And so we could do this dot name is equal to the name that's passed in, and inside of this run method, this is what gets run when the thread is spawned. So we're going to do thread dot current thread dot set name. Okay, this is that method that I was talking about, and we're going to pass in the name that was passed into the instantiation of the task class. Okay, and so for that we could just do this dot name, just so we're referring to this property of the particular instance. And up here, when we're instantiating an instance of the task runner, we can pass in the particular name that we want to give this thread. So I'll just call it thread-A, and over here it's going to be thread-B, and let's hit play. And that's all there is to it. You should have completed this assignment. Hopefully it wasn't too hard. So to start a thread, we use this start method on the particular thread. Again, this task is a thread, right? It extends the thread class. What does that mean in object orientation? That means it is a thread. That's how I want you to look at it. And so we're telling that thread to start using this start method. Now, we looked at the thread class a bit, and we saw that it implements the runnable interface. So when we go into the runnable interface, it's this run method that we have to override in our particular thread. Okay, so you might be wondering, hey, maybe there's a way to just, instead of in the task class, instead of doing extends, I could just do implements and then do runnable. It implements the run method, right? But notice that we're not able to invoke the start method anymore. The reason for this is now task is not a thread. It's a runnable. So we can't treat it like a thread. So you might, think that, okay, instead of using the start method, I could just do run, right? If we do this, now the code is compiling, but this is not multi-threaded anymore, right? We're not using the thread class. I'll prove it to you. If I hit play, notice everything is being executed sequentially, right? It's still doing thread A. There is no interleaving going on between thread A and thread B. It's only doing thread A. If we scroll all the way to the top, notice it's saying starting thread 1, and we don't see that starting thread 2. It didn't even move here. It's stuck here until it's done. Only then it's going to move to this line and so on. So you're going to notice that this is just like a regular basic Java program, similar to what you've been writing so far in the course. It's sequential, it's single threaded. The main thread is the only thread in this program, right? It doesn't actually have multiple threads running, just a single thread. And in that thread, it executes this line by line. Because we're not using the multi-threaded features. Just because we're implementing runnable here doesn't make this a thread. It needs to be a thread for it to be a multi-threaded program. So let's scroll down here, and you'll notice all of the numbers that are being printed from thread A, and then finally when it gets to 999, it's going to show that print line statement starting thread 2, and lo and behold, the rest of the numbers are all thread B. So this is certainly not a multi-threaded program, and that is why I wanted to show you that just using this runnable and then implementing the run method is not going to make this run a multi-threaded program. This is just regular object orientation, if you really think about it. That doesn't mean that we can't implement runnable. We can leave this as it is. This task is, we can say it's a runnable task, but we need to run it in a thread. And to do that, all we have to do is define a particular thread. We need to run this task on a given thread. So let's define a thread. We can say thread, and we'll call it T1 is equal to new thread. And then as an argument to this particular thread, we're passing in the particular task. So we'll say task runner. Okay. And now, instead of calling run on task runner, we want to call start on T1. So I'm just going to paste that here and just call start. And now this thread called T1 is going to be started on this line. Okay. So I'm just going to copy this code and paste it here. And instead of task runner, it's going to be task runner 2, and it's going to be T2. It's a different thread, and we're going to start T2. So here we're starting thread 1, and here we're starting thread 2. So let's hit play, and now you'll notice that we're back to the interleaving. Scroll all the way to the top, and you'll see starting thread 1, starting thread 2. This is proof that we're multi-threaded. It didn't wait here until the line is completed. Just continued to move forward. And if it saw a thread that needs to be created, it created a thread, started it, but didn't wait there. It moved on to the next line. Okay, so we're back to the way things were using this runnable interface. So we can implement the runnable interface on tasks that we want to be multi-threaded. All right, but we have to make sure that we're always creating a thread, okay, and then invoking the start method on that thread. So this is just another way of creating threads. Not only can you extend the thread class, you can also implement the runnable interface. I can make this code even shorter. Instead of defining an object called task runner, which is an instance of the task class, and we're defining a name, I could just copy this piece and pass it to the constructor of the thread class, just like that. And then we don't need this line at all. And then down here, I'll do the same thing. I'm just going to take this and pass it to the constructor of the thread class, and we don't need this line. All right, so we got a little shorter code. So now if you hit play, it's gonna still work as expected. Another way to start your threads is into the constructor of the thread class. I can define an anonymous class, an instance of a runnable, and we're not going to need the argument there, and create the open and close curly braces. So in the body of this anonymous class, we spoke about this several lessons ago when I was talking about object orientation. You can define your classes in separate files, or you can just define an anonymous class definition. Hover my mouse here saying we need to implement the unimplemented method. So let's click on this, and it's going to fill in the run method. And so in this body, all I would need is we could just copy paste everything that's in here and paste it into the body of the run method. And I could do the same thing for T1. So let me just copy all of this and paste it into T1. So we're going to change this to T1 for this thread, and this thread down here is T2, and we're starting T1 and we're starting T2 down here. Okay, so it's just another way of creating your own threads. Now notice that it's complaining there's no name property in this anonymous class definition, right? We just have this run method as part of this anonymous class. I don't have the name property, so I'll just get rid of that for now, and we'll do that here as well. Okay, so we've got two threads now. Let's hit play, and there you go. It's working as expected. Notice the name of the two threads is different because it's going by the default naming convention for threads, thread 0, thread 1, and so on. But it's doing the interleaving. This is a multi-threaded program. So that pretty much wraps up this lecture. I went over the different ways in which you can create your threads. You can have a separate class that extends the thread class like we did before, or you can have that class implement runnable like we did in this lesson, or you can have an anonymous class defined to the constructor of the thread class, and implement the run method in that anonymous class definition. But in all these different scenarios, the key is that we're creating a thread, all right, and then we're invoking the start method on that thread. So I'm going to wrap up this lecture. Thanks for watching. I'll see you in the next one.